Okay, so we're going to talk today about what we have learned from scanning 2K Kubernetes clusters. We're going to combine two of my favorite topics, Kubernetes and security, and we'll see it in a few minutes. So I really hope you won't get to this situation after my talk, but the agenda will be that I'll slightly present what Kubernetes, what security in Kubernetes is, and then we'll drill down to what's posture security and vulnerability scanning. Sorry. And last, we will drill down to what statistic we've learned from scanning clusters and even some more. Okay, so that's me. My name is Rotem. It's hard to pronounce, I know. I'm from Israel. I work for Armo, which are the maintainers and creators of Kubescape that we will talk later on. I'm a developer for 15 years. I'm into the DevOps industry around 5-6 years. And I really like practicing yoga and watching my favorite basketball team. And if we will go into the agenda and we'll start talking, then we'll start with what is now Kubernetes. So we see, and it's all very well known in some of the polls we made, and not just us, also Gartner and so on, that in practically Kubernetes is now the new operating system or the cloud operating system. And we saw that in a lot of polls. And basically, what attackers do, attack whatever is new, unsecured, and Kubernetes is now their new thing to go. So they are not off the radar now. And basically, the security solutions that we're having now for Kubernetes are not that, good as we know they should do, and attackers are trying to overcome them. So basically, we want also to have the security solution to be as fit as to the DevOps industry and the DevOps people. So who is using Kubernetes and security in practice, and why and how? So basically, we see that the users that are using Kubernetes are DevOps, DevSecOps, and security researcher are the last in the line for using those tools. And how often do they release a version? We see it's shortened, so weekly, daily even. And also, why are they using it? So scaling. Okay, scaling is the top word for Kubernetes, but also it's rapidly, it's make the development time a lot faster, and so on. So why do we need, that's a good one. Why do we need Kubernetes security? So Gartner says that 99 of cloud breaches will have a root cause of customer misconfiguration or mistakes. So yeah, it's a way to go into your cluster, and we all know that we are running those clusters in production and we don't want anyone to get in. And in the past 12 months, we saw that a lot of people are saying that misconfiguration and vulnerabilities are the most vulnerable parts in their cluster. So that's exactly what Gartner is saying. And basically, we want to protect two major paths, okay, in our cluster. The first path is what we're calling Kubernetes posture management. And this part can be applied also in the CI/CD path, in the pipeline. It can be done even before we're getting to the cluster. So actually, we're safe in this matter before we are getting into the cluster. But in the cluster itself, it's also a path that attackers can attack. And over there, we are focusing on runtime protection. And I'll get to both of those issues a bit later. But we will focus mainly on the posture management, and at the end, I will go to the runtime protection management, which is a lot harder, of course, to to develop and to maintain. So Kubescape, which is an open source tool that I'll talk about later, is becoming most popular in the open source community, in the DevOps community, and like generally in the security community. And we're seeing a rising open source GitHub repo that in, I think, about 3 weeks, it was, I think, last August. So in 3 weeks, we got around 4K stars in GitHub. So it was really impressive. And we really knew that this is a pain point for DevOps, for security researchers. And that's why it's getting, this traction. So Kubescape is going to tell you what you're doing wrong in your cluster, but not just. Also in your container registry, and can scan also for Helm charts and YAML files. And more important is not just to tell you what's wrong, but tell you how you can fix this issue. And our platform is like a cloud service, and it stores the Kubescape results, and it shows you like it's in a graphical way of how we're doing it. And lately, Kubescape was announced as CNCF sandboxing. We got accepted to CNCF sandboxing, which is really nice. Okay, so yeah, a lot of users, we talked about it from all around the world. But yeah, we collected lots of data, right? And now what we're going to do with that, right? So in order to drill down to the numbers and make it impeccable, then we use Kubescape and Armor platform to analyze the data. Basically, all the data coming from the clusters are coming to the Kubescape microservice, and the Kubescape microservice is just transferring it to the Armor platform, and that's how we can analyze all those things. So what we've checked. We've checked more than 6,000 clusters, more than 40 million Kubernetes objects, 178 registries, 1914 repositories, more than like 150K files scanned, and so on and so forth. So I'll talk about, several things, but comparing the whole sample, I'm going to compare the whole sample of graduated project of CNCF and like regular project that are out there in the industry, right? It's all just a code that we're running in our cluster. So I'll compare those two, and we will see how it fits. And we will see in right here what are the controls and the framework. So in order to have those statistics, not just to have this statistic, but Kubescape itself is divided to 2 sections, the controls and frameworks. Basically, the controls are the security tests that we are performing, and the framework are like the father of those controls. We have like several frameworks, like NSA, MITRE, and so on, that tells you this is a Kubernetes cluster. If you're compliant to this framework, so your cluster will be pretty much secure. Sorry. Okay, so what are the controls? So we're collecting Kubernetes objects, cron job, deployment, replica set, etc., and we're testing for specific phrase. For example, privileged container or service account token mountain, and so on and so forth. And the frameworks are, as I said, are a combination of those controls into one father. So yeah, let's get to business after this long presentation. So what we've really learned from scanning 10K cluster, more than 10K cluster. So basically, I divided here to the framework we're scanning, because we're scanning frameworks and not just specific control, because we think it's meaningful just to scan it all together. And what we've seen here is the average risk is around 28%. And we realized that if you're over 30% vulnerable, then you need to act, okay? And up until 30%, you're in a good shape, okay? Not in the best shape, but you're in a good shape. But up until that, then that's something you need to handle. So you see here the MITRE, the NSA, the RBAC. We're now supporting also the CIS framework, if you're familiar with. And we can say for sure 100% of the cluster we scanned had at least one misconfiguration, in all the cluster we scanned. But around 40% of the scanned has more than 14 failed controls, which is pretty much a lot when we check that. Okay, so let's even drill down and see what are the failed controls in general. So we see here the immutable root file system, the resources limit, the non-root. I'll drill down to everything in a minute. And we do see it in the graduated project, and the comparison will be right here. So we do compare between graduated and ungraduated project, and if we are drilling down to this specific control that I'm talking about, then non-root container control failure in graduated project, it was 84% of the cluster we scanned and 91% in ungraduated project. And if I'm going forward, the immutable file system, by default, you know, the container are permitted mostly unrestricted execution within their own context. So the attacker who has access to the container can create file and download and basically can do anything in the container. So if you have immutable file system and your cluster is failing on that control, then you're in a big problem. But 90%, you see, in the graduated project fail on that control. Okay, so that's a big deal. And also, disable automatic mapping to service account token failures also. And here we can see the difference between graduated and ungraduated project. And you don't want to limit the freedom, but you need to apply security context failure. Again, here we see the difference. And the control failed ratio on the failed control, well, all relevant controls per resource. Okay, also here you can see the comparison. So now we talked about misconfiguration, okay? You can, check in Kubescape. There are, I think now, around 200 controls up onto the severity thing. And this is just in the posture management. But there is this other side of image scanning and vulnerability checks. And what we're seeing here is that we're having a lot of vulnerabilities up there, right? CVEs from any different kinds. And basically, we can classify those to several topics by OS, by non-OS. And we can see that the number of clusters that has vulnerability, at least one, is really high, around 50%. Okay, so which orchestration they use? Kubernetes is around 96%. We saw that in the first slide. So what are we doing when we're scanning for images and vulnerabilities? So we're comparing. We're going to see how do we compare, the vulnerability part in graduated and not graduated project. We will review the distribution of severities and review top CVEs in each topic. And last, we will see the relevancy, which CVE is really relevant for our environment. So again, some statistics. So images repo with most scan in a general sample. So we see here a lot of repositories. We scanned, for example, Argo CD. Those are the number of repo that we scanned in our tool. So Argo CD, Redis, Argo exec, Prometheus, Bitnami, again Prometheus, the node exporter, and so on and so forth. So those are the top leaders that people are scanning. And in the graduated sample, we see a lot of people are scanning again Argo CD and Prometheus, but it's more than what people are scanning when it's not graduated. So what have we found? Those are the top CVEs we found in general population. Okay, I know it says nothing, right? Just seeing CVE with numbers and description and so on. So let's drill down to some of the CVEs that we found. So we found this CVE in the matter of BusyBox, and basically we investigate each CVE we found and understand if it's applicable to cloud native environment or not. So we see in this CVE that if someone is running a netstat in a port from terminal where attacker controls the DNS entry, so it's not a common scenario, okay? So that CVE is not really relevant, okay? And remember what I'm saying now regarding the relevant ports. And the other CVE is libcrypt, where is around many images and signature and everything. And again, it is mostly not in use, okay, in our environment. And the SQLite is a very important CVE, okay, but if it's exploitable, then the attacker can do whatever he wants in your cluster, basically. So basically, those are the really relevant CVEs we can see. Okay, just 2. We saw around 6. And I can tell you, and we'll get to it in a few minutes, that we're scanning for CVEs a lot of image repositories, and we're understanding that the relevancy of those images are not that high. We'll get to it in a minute. So again, the comparison to graduated project, and we do see here again a bunch of CVEs, their severities, and if I'm okay, something stopped working. Okay, let's do it that way. So CVE 2015. Then there is a CVE of Gripe. It is indeed a vulnerability, okay, in the C++ package. It's not a Golang package, so we're not seeing that so often in cloud native environment, but it is a valid CVE. Where is it? Okay, we're good. So basically, this is the only CVE that is not really relevant. So we do see the comparison between graduated and non-graduated project. So if we will look only on the filter result that we saw later, then the average vulnerability count per severity is really high in non-graduated versus graduated project, right? It's a lot higher. So yeah, I think you'll get it, right? You get it. The vulnerability in image, it's not saying that the workload specific is exploitable, okay? But what we did is something called Sniffer. Not sure that's the best name, but Sniffer, what it's doing is basically taking the images, reviewing the SBOM of the component or the image you're running, and it reviews the cluster. It combined everything together, and then we're creating like a tag SBOM just for the applications that are running in runtime. Remember back then we talked about posture management and runtime management. So here's runtime getting into the picture, because basically the images that are exploitable are the only images that are really running in runtime, because attacker don't want to bridge into an an application or image that is not running, right? He's not going to do anything with that. He really wants to bridge to something that is really running. So what we're doing is taking the SBOM and taking software bill of materials for the ones, you know, as I assume everyone knows what SBOM is, but not always. And we're actually collecting the files that are actually running on runtime and combining that together. And eventually, we are running the vulnerability scanner onto those images that we found. So after we ran that, then that's the picture. See, relevant images on to the general sample and the graduated project are becoming a lot, not a lot similar, but similar. We see the vulnerability part is a major part that we need to focus on. But you know, when you're seeing like 10,000s of CVEs, you don't know what to go and what to attack first. So this one is telling you exactly what you should do first and what's exploitable. Okay, so some closing thoughts from my end. We have the vulnerabilities and the misconfiguration. We started with talking about misconfiguration, and we see there is a difference between graduated and non-graduated projects, but generally, it's not that much of a difference. But we do see that many of the projects, graduated and not, are having misconfiguration in it. So that's thing that we need to pay attention to and check when we are thinking about securing our Kubernetes cluster. And the next part is the vulnerability part. And we need to be aware of what images are really vulnerable and where the attacker can attack from this side. We have those both sides that attacker can attack, right? And both paths are, you know, legible for the attacker. It can go either this way or that way. It doesn't matter. So we do need to fix our vulnerability, the vulnerability that are in high priority, that are really relevant for us, are top priority. So I guess that's it. Thank you very much for being here today. And, you know, if you have any questions, I'm here. Thanks a lot.